Bismillahirrahmanirrahim. My name is Yasir Fat and my group name is Muhammad Shehzad, and this project is supervised by Dr. Ahmed Ali Shah. So we have proposed this project WG based depression detection and monitoring the activities causing the depression and stress to human mind. So here is the table of content: motivation, problem statement or idea, aims and objectives, and literature review, brain and depression, methodology, EEG frequency bands, survey, data acquisition, data plotting, data splitting, and results, future work, and conclusion, and the references which I have given in the last. Motivation. The motivation of our project is to involve AI to develop a state of art system that can diagnose the depression that is quantifiable, accessible, and trustworthy. Problem statement. The problem statement of our project is that the depression is a common and serious medical mental stress that negatively affects person's thoughts, behaviors, feelings, and emotions. So the current traditional methodology of depression detection is that patient goes to psychiatrist, have a questionnaire session, and he is asked questions, and then the psychiatrist identify the depression according to his experience level. And this is the picture of a brain. It's 3 points: prefrontal cortex, amygdala, hippocampus. So the prefrontal cortex regulates thoughts, emotions, behavior. Amygdala reacts to stress and emotional arousal. And third one is stores learning and memory. So the depression mainly affects below the two parts of our mind, like prefrontal cortex and amygdala. These two parts of our brain are highly affected by the depression. Our idea. The idea of our project is to present a depression diagnosis system based on electroencephalogram signals, as electroencephalogram is a reliable and non-invasive technology used to measure brain activities. In this project, we commence to detect depression by processing EEG signals with AI algorithms. So the aims and objectives of our project: developing a reliable and deterministic system that can diagnose depression accurately and efficiently. The primary object of this project is to detect whether a person is in the state of art, in the state of depression or not. So, monitoring the mental health state in terms of depression. Literature review. So, we had read so many papers about the AI as the deep hybrid model using convolution neural network CNN, and along with the short long-term memory LSTM architectures are used to detect depression using EEG signals. So the second one is a novel hybrid neural network paper, which involves a hybrid neural network that can be identified as DEP-HS for depression screening. And the third one is EEG based depression detection using convolution neural network with demographic attention. So in this paper, the data was recorded of different ages of the people. For example, one was data recorded of 20 year, and second one is 30 year. So different ages were taken to record the data. And this is EEG based deep learning model for automatic detection of clinical depression scientific paper. So in this model was designed in which an integration of CNN and along with the LSTM was implemented for the detection of the depression. So the methodology of our paper is like designing questions first, then conducting a survey, recording EEG signal, pre-processing the EEG signals, applying AI techniques to analyze the recorded data, and finally comparison of the final results with data obtained through the survey-based questionnaire. So this survey we had designed like back depression inventory, which contains 30 or 21 questions, and its ranges are selected in which range the person is in a conscious state, in borderline state, or moderate depression, or a severe depression, or a extreme depression. So the data acquisition, we acquired the data of 30 participants using the four sensors which were in the Muse headset, and we recorded the data for 60 seconds. And there were four sensors like AF7, AF8, and TF9, TF10. Data recording. We recorded EEG data via Muse headset. The data was transferred and saved in CSV format on Google Drive by Muse headset. Then the data was further processed on Kaggle online platform. So here is the combined signal graph. Like uh, this graph contains different frequencies of signals, different signals of frequencies. So here is different signals like delta, theta, alpha, and beta. So these four signals having the different frequencies are given when we had splitted the data. Data splitting. We have two classes in a data set: depressed, and second one is non-depressed. So the data set is further split it into two categories, like 80% trend data and 20% test data. Machine learning. So in this uh, slide, we can see that there is a feature extraction, means different frequencies, signals of frequencies are extracted, which we are used for our purpose, like theta, delta, alpha, beta, and gamma. Its frequencies are also given. We extract the signals from raw data and then process it. So the results. We can see that the delta and theta frequency bands are dominant, like they're written as 1, 1, and this graph shows that delta and theta frequency bands are dominant. So the second model is KNN model. So this model we applied, and its model frequency accuracy is 83.47%. So also there is also given a confusion matrix of KNN model and validation curve, which shows the testing accuracy and train accuracy. And the third one is the random forest classifier. This model accuracy is 97.91%. The random forest varying the number of n estimators, like testing accuracy and train accuracy. So the other models we use, like SVM, AAN, and LSTM architecture, and its accuracy is 75%, and second one is 79.81%, and third one is 83.59%. So the future work, what we are going to do to increase the data set by least up to 100 participants, to build a platform that can process the real-time data, which will help the patients who are depressed can identify their depression. So the conclusion, the EEG based system is best being developed that can diagnose depression and activities that are the root cause of depression. So the purpose project is quantifiable, accessible, and trustable. Here are the references which we have read different papers, and we have given these references from the different journals. Thank you.